So I'm pleased to have Jules here. I'm really pleased he agreed to come up and give this talk for us. I'm sure if you don't know much about Jules, I'm pretty certain you would have used some of the software he's either developed or some of the code and software has been developed based upon. So thanks very much, Jules, for coming up. And I'll pass it to you.
Thanks very much. Really nice to have the excuse to come up to Edinburgh. I've been there loads of times, but I was actually walking up just thinking when was the last time I came to the university, and I think it was probably in 1989 when I came here to be interviewed for a place here to study computer science, and you rejected me. But that's fine. That's fine. No bitterness. Like David said, you've probably used some of my software, but I'll do a quick intro for those of you who don't know what I've been involved with, just for some bit of background context, so you know where my biases and my opinions may lie. Juice is my main gig, my day job, and the reason I get invited to talk at things like this. I'm sure some of you are familiar with it, but for those who aren't, it's a big C++ library. I started it about maybe 15 years ago now, and it's grown over the years. It's got a huge range of stuff inside it. It covers graphics and GUI and threading and containers and all the basics you need for a big toolkit. But its little niche is in audio, and especially in building audio plugins. And that's where it's really taken hold, and to the point where it's pretty safe to say now that probably most audio plugins you're going to see will probably be based on Juice. Juice is owned by Rowley, who you may know for our squishy silicon piano keyboards, C-board, and our blocks range. There's actually another one there, which we product shop. At Rowley, I as well as working on Juice itself, I also get involved with architecture of the other products that we do. So I work on apps, mobile apps, embedded firmware, all different things, and sort of guide the architecture for the team there. I also have another company, Traction, which is even older than Juice, and I started work on that probably when some people in this room were wearing nappies. I think literally. And that was a DAW that was back in the days before the term DAW even existed. We used to call it an audio workstation. That's still going strong, and we're up to like version 8 of that now. Changed its name, it's now called Waveform. And we do other plugins and hardware products as well for that kind of thing. So basically, I've done loads and loads of stuff all in audio, which is, so for my sins, I've kind of got experience with lots and lots of stuff, and I've made all the mistakes. So I've been asked here to talk about kind of at a high level, do's and don'ts, how to approach this stuff. So what I'll talk about, a few vague sections in the talk. I'll go through tools of the trade. So assuming that some of you are new to plugin development or thinking about it, then like what you need to get started, what are the good and bad things to use. I'll talk about what kind of stuff you'll expect when you get stuck into it. Common misunderstandings. I've got my own little list of bugbears and things I hate and things I like and things I'm sick of seeing beginners get wrong, so I'll go through a few of those. And give you some non-audio tips and tricks, and maybe if we have time at the end, talk about future stuff, hand-wavy kind of what's coming up next in the world of audio kind of things. So it's an AES event, so I'm not going to start from even though I was asked to keep this pretty high level, I'm not going to start from the digital audio is made of little slices called samples, and I'm going to assume some sort of level of basic digital audio knowledge from you guys. I'll dip into code a little bit, but I've only really got a couple of slides of code, so it's mainly just me ranting about things you should and shouldn't do, I think. But just to get a feel for how I should be pitching this, like a quick show of hands, like how many of you would consider yourself like a proper programmer? Okay, so quite a few. And so who's done a bit of programming, maybe written a plugin, maybe done a bit of audio stuff? Okay, so you're all, yeah, that's good. So I won't be like, I won't be shooting over everybody's heads if I start digging into some coding stuff. But I'm not, it's not a coding talk, it's not a C++ conference, so I'm not going to get really deep. It'll be mainly high-level things. Okay, so I did talk a while ago, I think it might have been an AES talk as well, for some students where I was pitching the idea of, it was like, should you work in the audio development industry? And I quite liked these 3 points that I summed up as the best traits you should have if you're the ideal person to work in this industry. So, you've got to like music, duh. Like, it goes without saying, but if you look at most companies like Rowley, you're going to find most of the people who work there, they're all really good musicians. They've all got an instrument they play much better than I do. Half of them have got like 2 or 3 bands on the go, or they're a DJ or something like that. So, you know, it really attracts people who are really into the music, and that's why they want to do this stuff. You also need to really like very, very hard programming challenges. And that's what I really want to emphasize in this talk, if nothing else, is like how difficult audio programming is. I actually can't think of any other like, mainstream area of programming which has as many difficult parts to it as audio programming. If you're in the audio industry and you're say a hardware designer, electronics designer, you're not going to have quite such a hard time. That stuff isn't quite so cutting edge. But if you're in the audio biz and you're writing software, you're really going to be up against some really, really difficult challenges if you're making proper, pro-level software. So I'll talk about some of the reasons why that is as we go on. But if you want to get paid really well for, where's this? Having some problems with, yeah. Slides. Okay, but the number 3 that should be on there, I've just copied this across from, well, I've got the wrong version. But number 3 that should be on there is very mediocre wages. Because if you only get paid really well for doing really easy coding, there are ways of doing that. Go and learn JavaScript and become a web developer, and you'll get paid pretty well. Problems are not that hard. You might have to work some late nights, but it's not intellectually that difficult. If you want to make a lot of money and really hit some really big intellectual challenges, then go and learn algorithmic trading, become a quant, go and learn about finance, go and work for a bank, and do some of the really difficult stuff there, or learn about scaling to large networks, go and work for Google and design these huge scalar systems. Or you can do audio programming, where you get to work on problems that are at least as difficult as those high-frequency trading algorithms and those network scaling problems. But you don't get paid very much because the people who do it for the love rather than the money. And that's either good or bad, depending how you look at it. So, tools of the trade. I'll talk a bit about the sort of things you need to get started doing this. Number 1, learn C++. And sorry that straight away the number 1 thing you have to do is go out and learn probably the most difficult programming language there is to master. If you're hoping you could get away with working on writing audio code in JavaScript or Python or Visual Basic, then you're going to be pretty disappointed because all the serious companies will use C++, and there are reasons why we do that. And sure, if you're working on a non-real-time application, then you're going to be fine. You can, if you've got some WAV files and you're doing some processing on them, and you're going to convert them to something else and run this as offline processing, then you can do that in Python. You can do that in Excel. That's fine. But when you actually get down to this real-time programming, you're going to need to have complete control over what you're doing, and that's why C++ is really the only game in town. We absolutely learn other languages because that's an interesting exercise. It's very useful to do that, to know what's out there, but you're going to have to come back to C++. And the main reason for that is that in audio, one of the things that makes it really difficult is not just that it has to be very fast, but it has to be real-time fast. So you're up against like hard real-time limits. If you're writing code to run on a supercomputer, you want it to be run very fast because the more efficient it is, the less power you're going to use, but it doesn't matter how lumpy the performance is. When you're working in audio, you're up against the problem where if just once your code takes slightly too long to run, you're going to get a huge glitch. You might be playing through, a stadium sound system. It's going to be bad news. And when you actually have that constraint on what you're doing, it becomes a very difficult problem. There's a good series of lectures by our colleague Tim Odula, and he actually spanned this out to, I think, 3 hours of lectures. So real-time programming in audio is not simple. I'm not going to go into it here. It's tough, but it's one of the things you can only really do in a language where you have control, like in C++. So, I actually love the language. I know lots of people who like it. I know lots of people who've learned to tolerate it. It may be Stockholm syndrome, but if you don't feel you can reach a good relationship with the language, then you probably also don't quite have the right mindset for this kind of work, because it's really only the real control freaks who write good software. And also, while I'm having a rant, please don't learn C. I could talk for another whole hour about that, and there are talks from the C++ community about why you shouldn't learn C. But it's one of the things that the modern C++ advocates talk about that makes us all sad is the sheer quantity of people who learn C and then learn a few extra things in that C++, and then they go on to generate all the shoddy C++ code out there, which is basically C with a few bits. And then beginners come along and they see that and they copy that. And the whole thing, it's not the right modern paradigm. So what people are advocating now, and if there are any teachers in the room, please do look into this, is that you should, when you have students who are new to the whole area, please teach them C++ first. Ignore all the old stuff, ignore pointers and malloc and all the old things. Just show them new, modern C++, and let them get used to that, and then they can learn about all the dirty stuff behind the scenes later when they need it. But you end up with people writing much safer code and using all the modern safe paradigms that we try so hard to make people adopt. But every day on the Juice forum, I see people just writing this old-fashioned code, leaking, it's just awful. And just also on this, before I move on to not ranting about languages, do please, if you're just starting, spend some time learning the basics of the language before you dive in and actually do something. On the Juice forum, a really large proportion of the cries for help we get on that are beginners who have come on and said, I'm trying to write my amazing plugin, this idea, but I can't get this bit of code to compile, and they paste it in and it's just gibberish. And they just don't know really how to do the syntax. And they might have the best idea in the world. It's like, you could be trying to carve the greatest sculpture in the world, and you might have in your head exactly what it should look like, but you've got to know which end of the chisel to hit. And it's worth investing a bit of time at the start before you get too deep to avoid that slowing you down and putting you off when you get going. And I know this isn't a programming lecture, but one slide from my one big tip for anyone learning to program in any language is DRY. Who in the room has heard of dry? Oh, that's better, half a dozen. It stands for don't repeat yourself. And you can Google for this and find much better explanations of it than I can do. But the essence of this is that if you look at some code and you find yourself thinking, oh, that's like, they've done the same thing here, there are patterns in the code, that you're doing the same thing in a few places, then that's bad. The superfluous repetition is a sign that you should be taking that code and boiling it down, abstracting away, taking that repetition, turning it into a function, turning it into something else to make the whole thing tighter and less repetitive. And it's odd, it's hard to explain why this is so important, but once you actually get a feel for it, it becomes a sort of metric. And like when we're doing code reviews at work, we might look at some, we might be reviewing someone's code and we'll go, this feels a bit wet. It feels like it needs drying out. And once it's an ephemeral thing, but learn about it if you haven't already. And next time you're writing code, ask yourself, like, could I make this less repetitive? Can I make this tighter? And if you keep that mindset, you will write better code. Not just audio, but generally. So, tools of the trade. I'm not a fanboy, although we have a lovely relationship with our Apple friends at Rugby, and we like them very much. I have an Android phone, and it makes me sad to give this as a piece of advice, but tools of the trade, you're doing audio, you're going to have a Mac. And that's unfortunately because if you have a Mac, you can develop PC software on it, but if you have a PC, you can't develop Mac software on it because Apple won't let you. So because in the music world and the audio world, such a big proportion of our user base use Macs, you're going to have, whatever you do, if it's a plugin or an app or something, you're going to have to end up building something for Mac at some point, even if it's an iOS app, you're going to have to do it. So what most people do is, like, I have Parallels on this thing, and I mainly use Xcode, but I can do my Windows builds on there. I know other people who can't stand the Mac, so they do most of their work on their PC using Visual Studio, and they have like a cheap iMac or something, like a Mac Mini, that they do their builds and testing on, but you're gonna have to get on at some point. I recommend the Mac Pro. Then I've got a new one here, which is lovely, as long as you don't want to turn up at a random lecture theatre and plug it into anything. Or carry around a big bag of dongles, but not have the right one. But hey, it's pretty. So you've got your compiler, you've got your computer, you're going to write your amazing plugin, and you're going to need some tools and libraries and code to build it with. So you can't just open up Xcode and start writing a plugin. You can, it'll take you a while. Pick yourself an IDE. Most people will use probably Xcode or Visual Studio. There's a million other editors, as you know. You can have your Vim and Emacs crowd. You have Sublime, all these different things. So that's nice and straightforward. Then you'll need some SDKs if you're going to attempt to do a plugin. So you'll need obviously 2 or 3 SDKs. You'll need your audio unit ones if you're building an audio unit. If you're building an AES, you're going to go through months of trying to get permission from Pro Tools to actually build one. So you need to get all that stuff set up. Maybe out there's someone who could offer you a toolkit that makes all this stuff easy by abstracting it away. I don't know. Juice isn't the only game in town for that. It's just the best one. Whatever you choose, however you choose to do it, even if you choose to go the hard way and actually develop differently for all the different platforms yourself and not cut out the toolkits and middleware. One of the other difficult things about writing audio software is the sheer number of different platforms and combinations of operating system, plugin format, host, everything that you're going to need to test on and support, which is why things like Juice actually have a market. It's because we cut out some of that. Because if you're going to have to test everything you do as a VST2 in Logic on Mac and a VST3 on the PC in Cubase, and there are thousands of combinations. It's basically impossible to do, but toolkits and leaning on other people's work can help you cut that complexity down and get started more quickly. What kind of hardware do you need? That is not a picture of my home studio. My home studio at the moment actually consists of this laptop, monitor, some old, slightly wonky headphones, and a keyboard and a mouse. I used to have a pair of speakers, but then I moved house and they didn't fit. And then I was going to get some new ones, and then I realised I didn't really use them much. So I haven't got any more. So actually, you don't really need much these days. To be fair, I spend the vast majority of my time staring at code rather than listening to sound. If you're a sound designer, you're going to need a proper room, proper setup. But like, even if you're a DSP programmer who writes synthesizers, you're probably not going to spend that much of your time really listening to sounds. You're going to be spending 90% of your time optimizing for performance on a particular Android phone, or fighting with a particular version of Ableton in which a parameter doesn't work properly, or that kind of stuff. So, having a crazy over-the-top setup like this is probably just torment, because you're never going to get to use that stuff. And one of the annoying things I find about doing audio work as well is you end up not being able to actually listen to music while you do it, because you're kind of busy. You're probably going to need a MIDI keyboard controller if you're doing anything that involves synths. You're going to need to get some notes in there. I've heard rolling C boards are quite nice. I don't actually have one at home. I've got like a block that I use if I really need to get some MIDI notes in there. But I play guitar on keyboards anyway, so it's all kind of lost on me. And in terms of an I/O box, I mean, I actually don't. I have a box somewhere that's got a few old audio I/O cards in there that I don't use anymore. And to be honest, you probably don't need them unless you're actually testing something like multi-channel recording. You're probably not going to really need that very much anymore. Maths and DSP. Now, to do this slide, I googled for the equation for the Fourier transform. Apparently that's it. I'm not very good at this sort of thing. I'm not much of a mathematician. So maybe that's why I didn't reject it. But there are probably lots of people in the room who are much better at this than me. But the point being, you don't need to be great at it, because there's so much of what happens in the world of audio software that doesn't involve maths or DSP. It's a huge topic to get good at this stuff. At work, I've worked with a few really talented people who get this, and I'm always impressed by the things they say, which I don't understand. But even they probably spend 1% of their time standing in front of a blackboard working out a great equation for something, and again, 99% of their time optimizing those neon instructions for Android, or trying to fight with some weird glitch that happens once a week on this particular device. But for the rest of us, like, if you're going to work in this field, you kind of need what I would call conversational DSP, which is the ability to know enough of the terms and kind of get the gist of enough of the principles behind it, that when you are talking to someone who knows what they're talking about and they start going on, you kind of know when to go, oh, right, you know when to nod to make it seem like you actually have a bit of a clue. I mean, it's fascinating. I hope you all know loads about it and go on to study this stuff. But it's such a small part of what's actually needed overall. Looks like the fonts are missing on this machine. There should be another line there. Yeah, thanks. What that should say, I think, is real-time, hard real-time. So here, like, in terms of important things to know, DSP is kind of important-ish, but really, if you're doing this stuff, no matter what you're doing, whether you're doing DSP or the rest of it, you really have to kind of have a pretty good grasp of threading, the problems of threading and the problems of hard real-time coding, which is hard because the human brain just isn't designed to do that. I don't know how you learn properly to visualize threads. It took me decades to really become any good at it. But it's inherent in all audio code, because whatever you're doing in audio, you're going to have one thread doing the audio and some other stuff going on. If that's just your user interface, you're lucky. But more likely, you'll have some threads loading files and getting things ready for the audio thread, and things get really complicated, and you have to not glitch. You have to keep these things all running nice and smoothly. And it's a really hard problem. It's one of the many audio hard problems. I've already mentioned like the hard real-time problem, which makes it even worse. So you have to end up understanding like lock-free programming, so you can just smoothly work with this real-time thread. And multi-threading, normal multi-threading between for other stuff, it's hard, but unfortunately necessary. I tried to do a couple of pie charts here, based on my kind of overall feel for, in this case, how much code you end up having in a normal OEM, anything in this kind of space. A little bit of DSP code. It might take you 10 years to come up with that amazing algorithm to do that noise reduction, but it's going to end up being just a little bit of code that never goes wrong. Then you're going to have scads of GUI code, you're going to have just some other stuff, random glue code, plumbing. You're going to worry about your data model all the time. And you're going to spend a lot of time doing this other stuff. Certainly in an app like Traction, a door, probably there's no way, that's about the sort of the proportions that we have. There's very little actual audio code. It's mostly just things that put slides on the screen and move stuff around and make sure they're all synced up. This one is more about the pain. So you're gonna, the amount of time you spend on things, the amount of time you spend debugging, the amount of support you end up worrying about. DSP goes up a bit because you worry about it more, but you're going to spend a lot of your time messing with Git. You're going to spend a lot of your time deploying things to app stores. You're going to spend a lot of your time debugging a certain version of Cubase that doesn't quite right for some reason. If you're lucky enough to have enough users, then finding doors goes up, because they're going to find weird edge cases. Okay, common misunderstandings. So, I've tried to come up with some things that are obvious to anyone who's just been doing this for 20 years. And this is mostly based on my observations of stuff that people don't understand on our forum when they're coming along. Beginners come along and they ask us questions. So, what can a plugin actually do? This seems to be quite heavily misunderstood. Some of these it can do, some of these it can't. So, these you can do. You're running a plugin, you can get some audio in, you can get some MIDI in, you can stream that audio out and stream some MIDI out. Great. Streaming it. You can twiddle your parameter levels. So if you're writing a reverb, you can tell the host about your room size parameter. Read and write that. That's easy. You can ask the host what time you're currently playing at. It'll tell you samples, it'll tell you seconds, it'll tell you even bars and beats within the timeline. But then we get questions where people say, well, oh, hang on, these are all in the wrong place because the fonts are wrong. Obviously, we can also draw a GUI. But the point being here that it's inside a window that the host provides. So many forum threads about like, oh, how can I put my window inside a track? And you're working inside a very constrained space as a plugin. The host will provide you a little window, you need to just keep inside your little window and don't try and go outside it, because bad things will happen. You also can't see what's coming up next. The plugin can only stream. You can't ask the host, hey, what track am I on? Can you give me everything in the track and let me diddle around with it and render it and give you something else to put in the track, which is something we get asked all the time. Because many hosts won't even have tracks, so the question might be kind of meaningless. And there's nothing in any of the plugin formats to let you do that. You can't there should be some other points on here that have gone at the bottom because the fonts are on. Trying to remember the last one. Can't remember. But, oh yeah, and the last one is communicate between different instances of the plugin. And that's a sort of half, yeah, it sort of can. In the past, it's always been quite easy. All the instances of your plugin all share the memory space, but now the host is starting to sandbox you more. It can become something where you have to really work in order to do that. But it also seems to be a really common thing that people want to do. They want to have plugins that stream audio between one track to the next. But people are, you have to really limit your worldview when you're working in this space, because the formats it's the lowest common denominator. A lot of hosts don't offer a lot of functionality, so the plugins can only do the minimum that the hosts can offer. The other thing that beginners seem slow to grasp is how audio gets processed, and it's not surprising, because it is a strange way to do this. The way we actually do audio, it's not obvious that audio should travel around in buffers. But the thing people don't get is that in the vast majority of actual real-world programming models, whether it's a plugin or writing an app that just plays some audio through the audio device, there's something outside your control, whether that's the host or the operating system or a library like Jules, and that thing is going to be pulling. It's going to be pulling buffers from you. You're never pushing audio. There are some programming models where it kind of seems like you are pushing, but really what's happening behind the scenes is it's always a pull model. So the way that most people would expect to come along and write something like a sine wave playback, this is just pseudocode, would be that you just loop, you create your next point along the sine wave and you play that sample. And that seems really obvious and nice, and that's a great way to write it. But that's not how you write it. There are tools like if you're messing around with something like processing or Maximilian, or you're doing a max MSP patch, you kind of got more of this sort of a model. But in fact, when it actually comes down to doing proper performance audio, you're going to end up with something much more messy, like this, where you're getting given a bunch of channels and a block of samples, and maybe 256 of them or 128, and you have to fill them, you have to loop around them, and probably the number one biggest confusion we get on the forum as well is that when people are doing this, we constantly get, I've written a filter, but it sounds all crackly. And you look, here's my code, and you look at the code, and they're looping around, say, 2 or 3 channels, and they're just using the same filter on each channel. So they're doing a block of audio, and they're going channel 1, channel 2, just passing it all through the same filter. Because this idea of working not in a contained world where you have state and you're just worrying about one stream of audio, but having to be presented with this big block of channels of samples and deal with it and work out multiple versions of your state for each channel, is a kind of mental leap, and it's annoying that people have to learn it, but sadly that's the way it is. And it's really very hard to educate people from day one about having to do this. The other big misconception a lot of people have is about triggering sounds. Like, so many times I've had people try to write a metronome and said, and the way they expect to approach that is by having a timer that goes off every time there's on the metronome's frequency, they expect to trigger a click sound. And that's just not how things work. I mean, maybe if you're programming a game, that is kind of how the model works. But the idea that to do a metronome, you have to actually count samples, and you're not. It's not a free-running process. You're pretty much rendering that metronome. It's almost a functional process where, at this chunk of time, I know there's going to be a click at sample number 37, so I'm going to start rendering on my click there. This is a kind of a mental model that's quite hard for beginners to grasp, and we very often explain that on the forum. It's the same. I mean, the same thing applies all the way up to. I think most people's initial idea of how you'd write a DAW would be you have events happen, and as the timeline moves along, you trigger the clips to be played on different tracks. But it's entirely not like that. It's all much more functional. It's much more, slices of time during which you render all the clips, and that's actually, once you get your head around it, that's fine. But it is hard to explain. Another really big misconception is that you can't intercept audio from other apps. So many times you get people saying, I want to write something that can get the output from Logic and add a reverb to it or record it. And the operating systems don't let you do this. They probably could. You can do it with MIDI on OS 10. I think probably the reason you can't do it in the operating systems is because they're stopping you just recording the output from copyrighted material, and it's probably a legal thing, but I don't know. But you can't, and the only way you can do this is to install your own custom audio driver that can grab the samples and do something fancy with it. So, common misunderstandings about performance. I love this one. So many debates. If you go on KVR and look at debates about 32 and 64-bit audio quality, whether you do your maths in 32 or 64 bits, I can't hear the difference. There are a handful of places where you actually need higher precision, but this is one of those things where I get even beginners asking, like, oh, how, I want to make sure the thing I'm writing can work as using doubles rather than floats because I want it to sound better, and this is before they've even mastered the syntax of the language. We have an interaction, we have a tick box you can turn on to do the bus summing using 64 bits. It might as well just be a dummy tick box, you can't tell. These are the famous two rules of optimization, not talking about quality, but talking about code optimization. First, don't optimize yet. What this is trying to warn you against is premature optimization. And even in audio app where performance really is important, it's probably only important for that little sliver of DSP code. The rest of the app probably doesn't matter. You could add a third rule here for audio, which would say something like, well, yeah, actually, this bit's going to need to be optimized, so you might as well do it from the start. But even then, the rule is don't optimize until you've actually run a profile and worked out what the hotspots are. Because CPUs these days are very weird. Nobody quite understands them. Compilers are very smart. And even when something is not performing as well as you need, you have to get in there, you're probably going to do it wrong. If you just look at your code and go, oh, that'll be the slow bit, you're going to be wrong. You need to measure this stuff, and then you need to measure the effects of your changes. So, it's got to the point where pretty much nobody is clever enough to just do that and get it right. You need help. And love your debugger. It seems like I'm moaning a lot about beginners on the forum, but probably the most annoying thing that we see are all of the helpless posts where they say, oh, I've written a plugin, but it crashes. Can someone tell me why? No. Nobody can. We're not psychic. But hey, you've got a tool on your computer that's already installed, which will tell you exactly what's going on. And the number of people who will not debug something, come onto a forum and try and explain and get help for it before they've actually looked at what's happening is really, really disappointing. There's, and also as well as just helping out finding what's wrong, actually stepping through code with a debugger is a really useful thing for beginners to do because it shows you what's actually going on. Stepping through is a really good learning tool, and I wish we could force people to do it somehow. It would save us a lot of time. So, this section is sort of non-audio chores. Like I said earlier, unless you're doing something really basic, you're going to spend an awful lot of time building a GUI. Probably the most time we spend on anything in a typical plugin. Exactly how you do that, again, it's beyond the scope of this kind of a talk. In Juice we provide like a huge GUI toolkit. There's far more GUI and graphics code in Juice than there is audio code. And that's because that's the bit you need, and you need to do an awful lot with it. There's a lot of other options now. I'm kind of old-fashioned, so I kind of recommend staying away from the newer, trendier GUI technologies like React Native and that sort of stuff. because I'm a bit more conservative, I like the native languages. I've seen people get into trouble with these more abstract ones because, you know, when you've got a layer of JavaScript and a browser embedded in there, and you're trying to optimize for performance and memory size and things, there's a lot more that's outside your control. Whereas if you stick with some of the more native approaches to doing GUI, then at least, you know, there's less code, you can see all the way down the stack, you have a lot more control over what's going on. But, you know, stuff's moving, it's changing very fast there, and there's a lot of options. But pick one and get stuck in that. The one bit of advice I give about any kind of GUI code, and one of the big things that's important to get right from the start in a project is just about separating and making sure that you structure your code well from the beginning. And when you start out programming and you're not very experienced, writing code feels kind of difficult and slow. So you end up trying to make things work in the most obvious and immediately gratifying way possible. So say you're building your reverb plugin and you want a big knob on the screen which is reverbiness, and you've spent a lot of time working on the DSP code, you've got your reverbiness variable that you can change, and you've spent a lot of time learning all this huge amount of GUI code, all these classes, you've built this thing and you've got your big knob on the screen, you've written verbiness above it, and you're trying to make that control the verbiness. It's really tempting to just set that variable. Go, oh, well, hey, you know, here's my GUI, here's my DSP code. I can just set that. It's right there. I can just set that variable. And when that variable changes, it's really tempting to say, oh, I've got pointers to my GUI code there. Someone can change the verbiness. I'm just going to nudge the button, nudge them, and I'll make it repaint. And that's great, you know, when you have one parameter, and then your code grows, and you start having all these connections between all these different bits of code, and you end up with a big ball of spaghetti. And as it grows, it just gets more and more unmanageable. And you start to regret that. When you've been doing this for a long, long time, you've made this mistake over and over again, you start to learn not to do this, but it's, maybe you have to do this wrong before you really understand it. And it's not like it's the end of the world. Like you can go back and refactor and chop up things that have got slightly out of hand. We did that with Traction several times. Like Traction, because it's such a long-term project, had a lot of code that became very, very spaghetti-like. But like one of the phases of refactoring where we split the GUI off from the audio engine was 6 months of full hard work from the two of us, just to unpick all these bits of string. And it would have been much better not to do that in the first place. I mean, you won't get this right. Nobody ever gets it right, but don't say I didn't warn you. So, on the subject of GUI, just a public service announcement. I mean, if you guys are the next generation of audio developers, please just let's eradicate this pestilence. To do this slide, I did a Google search for skeuomorphism, and I was not surprised. I was saddened, but not surprised to find that all the top hits are audio software, and it's embarrassing. You know, the rest of the computing world got over this decades ago. Well, not decades ago, but they've moved on. But we still get questions on the forum so often saying that I'm trying to build a knob of with a strip of JPEG images which are clearly a 3D rendered knob. I mean, it's uncreative thinking. Okay, if you are actually building a plugin which is actually a simulation of a real vintage amp, then fair enough. Have a picture of that amp and those knobs because you're emulating that actual real thing. But if you're building something new, then abstract this away. Think about what people actually want to control and come up with something better than just some knobs with fake LED text above them. There's any amount of like great user experience material out there to learn from, and people have thought this through a lot, and outside of the world of audio. So let's learn from that. Let's not just make this go away. There's all the other tools. There's a lot of tools involved, and I was trying to think of tips for writing installers and the logistics of selling your software and doing continuous integration and setting up build servers, uploading things to app stores. And the best tip I can give you for this one is what's worked for me in the last few years, which is to get yourself into a position where you tell someone else to do that. That works really well. I mean, for years I did run my own website, and I sold like Jules and plugins myself, and it's a complete, you spend so much time faffing around with the customer database, unlocking tools, and but it's almost hard to avoid if you're getting into the business, because if you're going down the entrepreneurial route, you're going to set up a little company and you're going to do this stuff yourself, you're going to end up doing all this stuff yourself. If you join an established company, then as the new kid, you're going to be the person who they make do this because they don't want to do it. So it's almost like an initiation, right? The future. I was trying to think of what the future is. It's funny how little the industry has moved on since I started. I mean, I've been doing this since about 2000, and we're still using VST2, which was what we had then, long before then. MIDI is 35 years old and going strong, and we're kind of in a tricky position in the industry because there are so many parts to it. Like trying to come up with a new MIDI standard is just almost impossible, because it would require all the plugin manufacturers, all the host manufacturers, all the people who make MIDI keyboards, all the people who make outboard gear, to all at the same time, or at least quickly, adopt a new standard and test them all with each other and get that working. And it's a huge chicken and egg problem with thousands of chickens and thousands of eggs. And it's hard to see how that could ever really progress. Web audio is interesting because it's come along and it's just come up at the side of all this. It's not bad. It's getting quite good now, what you can do in a browser. It's JavaScript, so there are always going to be limits on the performance, but it's getting better. And there's WebAssembly is the new native, well, sort of semi-native in-browser technology that should let us get close to native speed. But it's kind of hard to see how it's going to go beyond the novelty. I'm sure it will at some point, but to actually make it in a pro market, it's got to get over the hurdle of someone actually recording some serious audio in the browser. You've got a lot of data, and like doing that as a cloud service is tricky. It also, in order to have the kind of level of decent plugin support you need to do some pro audio work, requires all of the existing people to kind of port their existing plugins to the web somehow, but there isn't even a standard for that yet. So we'll get there eventually, and it's fun to play with. We've done some experiments with this at work, and it's cute, but it still feels like a bit of a novelty, but we should keep our eyes on it. Other than that, I don't think there's much going on. So learn C++, learn the old formats, and just try and innovate in what you do with it rather than the technology you use. That's pretty much it. Happy to do questions. I should do a plug for our conference, actually, which is ADC, like every year, because we started what was originally we called it the Juice Summit 2 years ago, and then we escalated that to be an audio developer conference in more general. and it's coming up in November, and we have a really, really great lineup. So that's down in London, but juice.com if you're interested in that. And one other quick plug is that we also have some internships that are only available, which we're interviewing for at the moment. So if anyone's interested in student level internships, let me know. That's for the Juice team. And other than that, questions, and thanks very much.
Fire away.
Yeah.
Hey, thanks a lot, Jules. My name is Jason. I run a company called Soundmorph, and we actually use Juice to make our first plugin called Dust. And so, thank you very much for developing it. It was really cool to use. I have a couple questions actually. One of them was an issue that we ran into with our first plugin was testing on different DAWs, which was something that you touched on earlier. And it was a big mistake that we made because we tested with like a few friends on a few DAWs and a few OSs, and then found out like, oh, you know, somebody's been running Windows 95 with like some old version of Pro Tools, and it really, it wasn't good for us, you know. So the only thing I thought was like, okay, we need to make this big Excel sheet of all the DAWs and all the OSs and map MPC and test that. Is there a solution that you can think of that might help us streamline that?
Not really. I think I've heard there is some testing company who I think used it for Traction at one point who would do this kind of testing on a lot of platforms. But the numbers are just against you because there are so many combinations. There's so many versions, so many hosts, so many, you know, to actually test every version of your plugin against it, you just can't.
Yeah, it turns into a support thing.
So we've mostly just...
I mean, do you think that then, I mean, because we didn't really beta test it. We were just like, okay, it's good. Let's put it out.
Yeah.
And then it was like, like nightmare of emails coming at us.
I think really the only way you can realistically do it is if you've already got a good enough user base, and then you get them to beta test your next version. That works because then you know you've got enough coverage. But again, it's still all probabilities.
Yeah. It's pretty much inevitable in a sense.
I know. You know, this is kind of one of the reasons that we have a business model, because Juice actually takes a lot of that away. Because you know, we capture an awful lot of those weirdnesses at our level. But then even we get here, even though there must be, I don't know how many hundreds of plugins out there that must be running on pretty much every platform. We still hear about new weird edge case version problems all the time. And yeah, probably nobody's got better coverage than we do.
Yeah.
So yeah, doing it yourself. I wish I had an answer.
No, it's okay. I mean, I was just curious what you would say.
Yeah, I mean, maybe we need to come up with a better plugin format that it's actually specified so clearly that no host and no plugin can possibly get it wrong, or be ambiguous, which is generally what the problem is. Like, oh, should you call this before that? Or should these calls be happening on different threads? It's like weird things that no one, where the hosting guy thinks one way and the plugin guy assumes something else, and it isn't fair.
Okay.
Yeah.
One other quick question. On your site it mentions a tutorial about wavetable, which we have been waiting to see for quite a while. I was just curious if there was an ETA on doing that at all.
I don't know. I don't do the tutorials anymore. But I don't know. It doesn't ring bells. But ping us on the forum and bump it.
Okay.
We'll see, because it might just be sitting there and no one's
used it. Thank you.
Well, thanks for the conference. I was wondering if you're a beginner in the industry, and if you have some knowledge, for example, I have programming knowledge, but I would like to know about these problems. You were saying you have to be invested in solving very complicated problems. Where do you look?
I would the unique, not unique, but the particular problems that we get are things like this hard real-time limit, which is something you don't get really. I mean, even in games and video and other real-time areas, they don't have this problem of you really have to run your code with hard limits. And to do that brings in this whole set of like lock-free programming problems. A really good resource for that would be some talks that you can find online. I think from CPPCon by a guy called Timur Dubler, who was on our GC team for a while. He's gone off to do something else now, but he did I think 3 talks. Really went into depth about that, and that's one of these programming problems that you won't come across quite such a problem in other areas. But that and multi-threading, exactly where you learn about that, I don't have good ideas. Our forum's a good place if you want to ask us, and we'll post some links on that and try and help out with that. But I think those are the main difficulties. And then the other difficult stuff is the DSP side, understanding DSP, which so that's maths. Yeah.
I am a great supporter of the new C++ like shared pointers and hate pointer arithmetic.
Yeah.
Do you have any suggestions for everyone, for any resources that anyone who's getting into C++, because C++ is a very long history?
And, I think cppreference.com is the main site these days. CPPCon is the big annual conference, and they've just had one a few weeks ago, and they're posting their videos, and there's some great talks on there by like people who are really at the top of the industry and who are getting more and more strident about making this point of like, learn the modern style, and here's why. And they explain it much better than I can. So yeah, CPPCon talks are great, and C++ Now as well is another conference that has. So yeah, watch some of those videos, and those guys do a really good job of explaining why this is. Sorry, Beth?
I apologize, my time if this is a silly question, maybe I was missing something. But you said during the common misconceptions that a plugin can't see what all your release coming out next.
Yeah.
But what about those plugins like a compressor, for example, the feature, look ahead feature?
Okay, yeah. It's hard to explain in a couple of minutes, but the way that you do that, because the plugin really it's tunnel vision. It gets told, here's your next buffer, give me a buffer. So it's this constant pull. It doesn't get the chance to say, hey, here's what's coming up in 1 second. And that might be because that 1 second doesn't even exist yet. You know, this could be live audio coming in from someone playing a guitar, doing effects on it. So what you do is, if you have, if you're doing some sort of effects where you do need to have like 1 second of audio and you're going to be processing that and working that far ahead, then what you do is you declare your plugin to have 1 second of latency, and then you just have to buffer that yourself. So you'll have your own little buffer. You've got your stream coming in. You're writing to your stream, and so once you've got a second of audio in there, at first you write out zeros because you can't do it yet, and then once you've got enough, you start doing it. So you're streaming 1 second behind what's coming in, but you've told the host that by declaring that you're latent. So the host should be, if it's doing its job properly, giving you, if you're on a track, the host will be giving you 1 second ahead of what it would be otherwise. Which works well, but you don't do it, the host does it. So you don't get to see it ahead, but the host will helpfully give you that if you ask it nicely. Let's start from the left.
Hi, I was just wondering if you could give some insight about what sort of backgrounds are valued in the industry. Like, I'm kind of an interloper, and I think that I have a good kind of general grasp of coding and learning C++, whatever, and conversational DSP, but like, you know, we say that the DSP doesn't get used so often, or probably people are still paying attention to
Yeah.
the DSP. Yeah, like, people look more.
It depends. I mean, I can talk about like who we employ at Rowley, where we have quite a big team. And sometimes we'll be looking for a DSP guy because we feel like we're lacking in that area. But we have maybe 3 or 4 really good DSP people, and the rest of the team is like another 15 coders who really, I mean, they get it, but they're not really doing that. So, you know, if you can do all of it, great. You know, if you've got enough DSP and enough just solid coding in the background, then that's good. I mean, personally, I'm more interested in how solid somebody's coding ability is than really what they know. Because you can learn all the background, you can learn the toolkits, you can learn that. You know, if you've got a mathematical enough brain, you can learn DSP as you go. But you know, if you're faced with a huge code base to learn, then that ability to just dive in, understand, write good code is the #1 day-to-day thing that you need to be good at. And that's probably true in most companies.
Yeah, so I guess I was asking, like, yeah, especially on the coding side,
Yeah.
you know, do you mostly kind of, I don't know, how do you approach someone who's like self-taught coding?
Yeah, if you're self-taught, then put together a GitHub site with your code in it, do a really great demo app, send that to us, and you know, if I know that when we get applications, I'm more interested in seeing someone's coding sample than I am looking at their CV. Yeah, don't care what you learn. Like you can usually see by looking at someone's code how competent they are, yeah, just prove it would be the best way. That's probably true. I don't know if that's true. You know, if you're joining a really huge company, it might be more formal and they might expect more, you know, more qualifications, but generally not. If you can show you can do it, that's the best thing. The back.
I see you saying C++ everywhere. Is it used absolutely everywhere, including sort of DSP and things like hardware controllers?
Oh yeah, I mean, if you're well, see, this is my bugbear. Like when you talk about firmware, it really should be used in all firmware because it's better for it. And there's a guy called Dan Sachs who did a keynote at our conference last year, and he goes around talking at conferences, and his thing is explaining why embedded programmers should use C++ and not C. And he's so right. When I came to Rowley, our embedded code base was C, and that was because the tools were really crappy and they only really had a decent C compiler. But then they migrated from like some weird manufacturer's own compiler to GCC and started migrating the code base to C++, and I was kind of very much making them do that. And it becomes so much cleaner and so much safer to program in that style. And the compilers are good enough. There's no embedded, you know, everyone's worrying about every cycle because these things are really need to be optimized to run on these tiny little CPUs. But actually, it's fine. C++ is more than good enough. So the answer is, do people use C++? And the answer is sadly not as much as they should. But yeah, they really should.
So there's no sort of assembly kernels anymore, anything should be.
You'd hope that on a typical embedded system, there'll be a bit of assembly code, probably in some manufacturer-supplied libraries. They'll do that, and if you've done your job right, you have lovely classes that abstract all that stuff and hide it away, and make sure you can never just poke the wrong register at the wrong time and make something bad happen. You can do that. You know, C++ is great for stopping you doing stupid things. C is not so good, but sadly, there's a mindset of the electronic engineer that kind of goes with C, and they're not so interested. They don't care about the high level stuff. I don't know, it's something to do with soldering. Yeah.
In terms of the quiz, we normally have like separate people, well, separate people. Obviously they have to collaborate, but would you have like people more specialized on, say, the design of it in terms of playability or interaction with the user, and then the TSP people?
Yeah.
How much?
If you're lucky enough to have a big enough team, then you will have, like at Roda we do have UX, user experience designers, and they just worry about the UX. They don't do any coding, they just do wireframes. And yeah, if you're lucky enough to have the resources to do that and get the right people to do that. It took us a while to get to that point. When I first joined a few years ago, we were doing products where we just made it up as we went along. And most small plugin companies, it'll be a couple of guys doing it, and they'll have some ideas in mind, and that's why you end up with these skeuomorphic interfaces, because they're not UX experts, but they kind of know what they want it to sound like, and they kind of know what kind of gear they're trying to emulate. I mean, yeah, if you're lucky, but whether that's generally the case, the bigger the company, the more likely it is.
And how important would you?
I think it's really important, actually. Having done it both ways, it's a luxury if you can get it, because by having someone just whose job it is to think through, like, the user journey through your software. I mean, if it's very simple, it doesn't matter so much. But once it becomes sufficiently complicated, having people just wireframing it out and trying out different paths through it, it can make all the difference between being a really great app and a really one that looks nice but is hard to use. So yeah, it's a luxury, but nice if you can get it.
What about Java? Because, for example, Android Studio is based on Java, so if you want.
Yeah, but they don't. You wouldn't. I mean, you can do the audio in Java, but nobody does. Like, our stuff runs on Android, but we kind of use Java as a very thin layer around the edge, and then all of the work happens in native code, and that's how most audio people will do that. And we actually know the Android audio team really well, the guys who work on that, and they have such a nightmare trying to get good glitch-free performance out of these Android CPUs, and that's because even when you take Java out of the equation, you're just doing native code on these things. The Linux kernel itself is not real-time hardened enough to keep it solid. Because actually just an hour ago Google launched a new Pixel 2, and the keynote was great because two of our guys from Roli were there playing our app on Pixels for in front of all these people as they live streamed it to 1 million people, this big Google keynote all around the world, and all of our buttocks are clenched. Oh God, don't glitch. Even though it's all in native code, because it's just, it only takes that one buffer to go on too long. And with Java, I think I've heard about real-time safe Java, but I don't think Android is. And certainly the Google guys, they don't do any Java stuff in their tests. I mean, we work with them, and doing it with native code is the way they recommend it. You don't want that garbage collector to kick in halfway through an audio packet.
Okay, I think we'll wrap up at that point. Thank you very much, Jules.